Cheng. I come from Yizhu University in Taiwan. My title is Fast SHVC Encoder using PU and MV prediction algorithm and the DSP implementations. This is my outline. First, introduction. Second, review of previous fast encoding methods. Third, proposed fast SHVC encoder. And experimental results. Final conclusions. First, introduction. The current state of the art video coding standard H264 is difficult to support the video application of high definition and ultra-high definition resolutions. JCT-VC has been developed a new high-efficient video coding called HEVC H265 for video compression standards. H265 has been adopted in video coding standards recently. Apple FaceTime, Microsoft Windows 10, Blu-ray Disc Association, 4K Blu-ray Disc. In order to upgrade the HEVC to using in heterogeneous SS networks, the JCT-VC developed a scalable extension of HEVC called SHVC. The function of SHVC include spatial scalability, temporal scalability, and the external scalability. Based on the HEVC, the SHVC scheme supports both single loop and multi-loop by enabling different interlayer predictors. The SHVC can achieve the highest coding efficiency, but require a very high computational complexity. The HEVC adopts 64 by 64 coding tree unit called CTU. The HEVC adopts the quad-tree structure CTU. Each CTU allows recursive splitting into 4 equal sub-CUs as follows. HEVC adopts some new coding structure include coding unit CU, prediction unit PU, and the transform unit TU. HEVC encoder enables 7 different interpolation modes, include this: partition near perform motion estimation (MV) and the motion compensation (MC). Since the MV process is performed using all the possible depth level and the prediction mode, which leads to require very high computational complexity in SHVC encoder. In order to speed up the encoding process of SHVC, there have been many fast encoding methods proposed to reduce the encoding complexity. Review of previous fast encoding methods. First, the temporal and spatial search order algorithm called TSSOA. In order to reduce the computational complexity of SHVC encoder, recently one proposed temporal and spatial search order algorithm TSSOA to find a good candidate quad-tree of the current CTU. Second, fast CU depth range decision called FCU-DRD. On the other hand, one also proposed the fast CU depth range decisions algorithm based on the maximum and the minimum value of the depth levels to determine current CU depth. However, every CU still need MV module to find the best PU mode for TSSOA and the FCU-DRD methods. For further improve the performance of the TSSOA and the FCU-DRD, we propose a fast PU prediction algorithm called FPUPA, fast MV prediction algorithm called FMVPA. And third, propose a fast SHVC encoder. As the high frame rate, the success to frame have a stronger temporal and spatial correlation. As shown in figure, the split structure of a CTU in the current frame, example for A and B, are the same or similar to the split structure of the temporally collocated CTU of the previous frame, showing A0 and B0. We can find they are the same and they are similar to. On the other hand, they are also the same or similar to the list structure of the special for neighbor CTU in the current frame. Example C through F as follows. First, there's a PU partition algorithm called FPUPA. First, we use TSSOA to find the PU mode of the best candidate, quadtree. And then the PU mode is considered as the best PU mode of the current CTU. The mode of the PU may be similar to the mode of the collocated CU and the special for neighbor CUs due to temporal and spatial correlations. The probability of the same CTU between neighboring and the current CU are using QP equal to 32. The value of the threshold is an important parameter which affects the coding performance of a proposed algorithm. The coding performance is evaluated by the comparison of a delta PSNRY and the TIR as follows. Since the proposed phase algorithm is very desirable for real-time implementation of a HEVC encoder, we focus on the TIR. Figures show the relation of the TIR vs threshold for QP equal to 32, which indicate that the TIR is approximately the same for all threshold more than and equal to 300,000. Since different QP could yield different detail of the image, consequently the threshold is QP dependent. Therefore, a polynomial fitting approximate a linear function is formulated as follows. Second, phase MV prediction algorithm called FMVPA. Secondly, five causal neighboring MVs of the CUs are considered as a good candidate MV of the current CU. The probability of the same CTU between neighboring and the current CU are using QP equal to 32. We find the probability order as follows. And the figure shows the relation of the TIR and the relation for QP equal to 32, which indicate that the TIR is approximately the same for all threshold more than and equal to 20,000. A polynomial fitting to approximate a linear function is formulated as follows. Finally, we combine FPUPA and FMVPA into the SHVC system to further speed up the encoding process. In addition, to further achieve the DSP relation for the proposed phase SHVC encoder, we embedded the codec on the ADSP BF548, as shown in figure 2. We reallocate the function of the consuming module from L3 to L1 and L2 to speed up the encoding time of the SHVC based on ADSP 548. And experimental results. Simulation conditions as follows. The proposed method can achieve an average TI about 17.8% when compared to SHM4. In addition, compared with the TSSOA algorithm, the proposed method can further achieve an average TI about 15%. And compared with the FCU-DRD algorithm, the proposed method can further achieve an average TI about 14%. Final conclusions. The proposed method can achieve an average TI about 66% to 88% when compared with the SHM4. This is correct that the proposed algorithm can efficiently increase the speed of the SHVC encoder with the insignificant loss of the image quality. Thanks for your attention.
Any questions? So some parts are similar to the previous presentation. This proposed method is suitable for DSP compared to the previous presentation.
Compared to another
This is suitable for DSP
yeah.
implementation.
Yes.
And can you merge